In this video, we're going to continue our study of the sketches of an antiderivative. We're given a function f of x, and we would like to generate an integral function of that. We can also think of this as going in reverse. Whatever we construct, we should be able to get this graph back if we differentiate it. The relationship, again, is values on this graph translate to slopes on the graph down here that we're building, and areas or integrals on the graph above translate to changes in the function f over the same interval. Now here we're asked to construct a detailed sketch of the antiderivative of little f, well that will be big F, for which the big F starts or has a value of 2 initially. Where does that lead us? Well, again, we have positive values all the way moving to the right. It's easiest to move from left to right. That's our natural inclination. We see a 0 value, though, at the point starting here, and that value translates to a 0 slope at that point. What happens after that? Well, we have positive values until we reach 2, and then at that point, the values here stay the same, so the slopes would stay the same down here. Again, that can be pretty tricky to sketch. We know roughly that it'll go up and get steeper, but we'd like to add a little more detail. Well, how can we do that? Well, let's take advantage of the second relationship. If we talk about areas giving us changes in f, let's take a look at the interval from 0 to 2. So asking, how does this graph change, what's the delta f, from 0 to 2? Well, we know that this is a triangle, and so that this area is going to equal 1/2 the base times the height. The base is 2, the height is 4, and that will be 4. And so on the same interval, we had better see a delta f of 4. Now we're going to probably want this a little smaller scale, so let's bring us down to here and call that 2, 6, 10, and 14, and so on. That'll give us enough room to work with. We said the slope had to be 0 initially here, and then the function will go up. It'll start flat and then go up, and by the time we finish 0 to 2, we should be 4 units higher. Ta-da! There is our graph. Then after that, notice the values here are constant at 4. That means we should stay with slope 4. That's easy to draw if it stays consistent. I take one step to the right, I go up by 4. Take one step to the right, go up by 4. And that is how we can build the second part of this graph. Notice, if we wanted to, we could talk about the area on this interval. That area is equal to 8, and lo and behold, on this interval down here, we changed our function value by 8 as well. So we're getting from 6 to 14. That is represented or captured by the area underneath, and it's really easy to do that when we just have the slope as a constant. Let's just back that up. When we draw these graphs, these are interdependent properties. Sometimes it's easier to use one rather than the other. Here we had slope of 4, and if we take a slope of 4, and take 2 steps, we knew we were going to go up by 8 anyway. This is just a confirmation because the area under this graph will have to be 8 as well. And that's a very powerful way to get a detailed sketch of a graph like this. Now moving backwards into the negative x is a bit tricky just because we're not moving in our natural direction, and so thinking about slopes gets a little more challenging. But all these values here are negative, and so what we know is there's going to be negative slopes coming in here. What else do we know? We're going to be coming down. In fact, we're going to have a same slope of -2 for a while coming in here. So it's going to be 10 to 8, 8 to 6, something like that. And then we can get a little more refined towards the end. This area here, better yet, let's say the integral, because it is below the axis. It's a triangle that's 1 by 2, so it'll be a half. It'll be negative. It'll be a half of the base times the height, which is -1. So here you have to be a little bit careful about your interpretations. But as we move from left to right, I should go down by 1. And then after that, we're going to see the slope of -2, slope of -2, slope of -2. And there we are. This is our sketch of the antiderivative capital F of x based on some detailed understanding of the original little f of x function. As you practice this, it becomes more and more straightforward to, let's go back to that. If this doesn't make too much sense right now, the key element is practicing and asking questions. If there's something you're getting stuck on, ask your colleagues, ask your classmates, ask your instructor, and see if you can tease out what is the stumbling block. Everything we do, though, comes back to these two relationships, values to slopes and areas integrals to the change in f.